Woohoo! Take three. Here we go. So, we're going to talk about the difference between mass and weight. Mass and weight are two different things. People use them synonymously as if they're the same thing, but they are not. And in physics, you have to be clear. It occurs to me halfway through the year that people are doing things and they really don't understand the difference between mass and weight. Fact. Mass is the amount of matter contained in something. I don't like saying matter. It's kind of nerdy. I say stuff. So I just call the stuff that something is made out of. I just call it stuff. But what we're really talking about is a measure of the number of atoms or molecules in something. So something that is more massive has more atoms and more molecules than something that is less massive. And that's the thing. Now, here's my issue. Okay. Look at this picture. Mass is something that is intrinsic to something. So if I took you and shot you up into space, or if I shot you to the moon right now at this very moment, boom, you're on the moon. Ooh, the ground's so soft, right? If you're on the moon now, you're going to look just like you. You will be you. If I was able to just shoot you up there. So your mass doesn't change. Mass is not something that changes due to location. Your mass is your mass. Now, can your mass change? Sure. If I shoot you up there with a whole bunch of pizza and you're sitting up on the moon eating a bunch of pizza, will your mass eventually change if you sit on your butt? Yes, it will. But from second to second, if 1 second you're on Earth and the next second you're on the moon, or you're in a different room, or you're shot out into space, your mass won't change. Okay. So if you look at these two pictures, you see that mass is something that doesn't change by location. But something does change, right? So what changes here? Well, the weight changes. Your weight is different on Earth versus the moon. This is a thing. Okay? You're going to weigh more somewhere, like Earth, somewhere else. You weigh less on the moon. Why do you weigh less on the moon? You weigh less on the moon because the moon is smaller. And if the moon is smaller, it has less gravity. And if it has less gravity, there's less force pulling on your mass. What's the difference between mass and weight? Okay, well, mass is an amount of stuff. Weight is not. Weight is the pull on that stuff. So weight can change depending on location. The moon is smaller. Because the moon is smaller, it has less pull. It has less gravitational attraction. Okay. Real quickly, let's talk about this idea of up versus down. Okay. Down to one person may not be down to someone else. If you look at this picture, you can see that, well, this person's down is pointing this way. Well, that person's down is pointing in the opposite direction. So down is kind of a relative term. Okay. We're really not saying something, goes down. So if I take my pen and I drop it, right, we say from the relativeness of this room that it's going down. Yes. But what's really going on here is that it's being pulled by Earth. Where? To the center of Earth. So we say that the gravitational attraction, this gravitational force, this idea of weight, is something that pulls us towards the center of a planet. And that little arrow can be different for different people in different places on Earth, which is amazing. And here's the deal. We live our lives in a field. It's called a gravity field. It's a force field. Okay. Which way does the field go? Which way does the field go? So which way does the field go? Make yourself big, right? So in the room right now, I'm being influenced by a gravity field. Which way does this field go? How do I figure this out? This is dumb, right? We know which way gravity acts. If I take a pen and I let it go, right, it goes that way. So what this is called a test mass. I take my test mass and I stick it out there and I just let it go. Like, I'm going to get up today and go, let's see which way my field is going. Oh, it's going down today. Thank goodness. Okay, now I feel okay. You have to have a test mass, something that you can test this on to see which way the field goes. And so our field lines, the direction of the field in this room is down at this location. So my field goes down. Okay. If you look at this picture here, you see that all the field lines are pointing towards the center of the earth all the time. So this will be the case no matter where you are on earth. So you have to have a test mass to figure out which way does the field go. Okay, now what is the strength of this gravity field that we live our lives in? What's the strength? Well, here again, I take my test mass, I let it go. What happens? What does it do? What does the test mass do? It doesn't fall. Don't say that. It doesn't fall. The test mass accelerates down towards the center of the earth. That's what we say. It starts at 0 velocity, and then as it falls, as it moves, it accelerates, it picks up velocity, picks up speed as it goes towards the center of the earth, right? Now, what's the strength of our field? We call this G. Is the strength of our field. The strength of the field is how much does the pin pick up speed? How much does it accelerate? And we call this G, little g. It stands for gravity or gravitation. On Earth, the strength of our field, little g, is 9.8, which means everything falls at that rate. What does that mean? Everything picks up speed at that amount. So what this really means, see how this says m/s/s, meter per second per second. That means that you are going to pick up speed at that amount every second. We call this acceleration due to gravity. On the moon is smaller. So G on the moon is not 9.8. It's only a sixth of what it is here on Earth. It's about 1.6. Okay. This pin will look the same on the moon because it has the same mass. But it's going to fall in a different way in the sense that it won't pick up speed quite as fast. G is different on the moon. So how do we calculate the weight of something, let's say in Earth's gravity field? Most problems are going to be on Earth. They're going to tell you that you are on Earth unless you're on some other planet. So G, little g, is a number that you're going to want to know, this 9.8. Here's the equation for the force due to gravity in Earth's gravity field. You take the mass of something and multiply by little g. So the average apple is about 100 grams, and if you divide by 1,000, that's 0.1 kilograms. So the weight of the average apple on Earth, you take m times g, it's about 0.98. So the average apple weighs about 1 Newton. So what can we say? What language can we use? We can say that the weight of the apple is 1 Newton. We could say that the force due to gravity on the apple is 1 Newton. We can say either of those things. They're the same. This is how gravity works. This isn't really how gravity works. This is how Newton came up with it. Hopefully talk about that later on in the year. Thanks for watching.